Good morning, everyone. Today we will continue discuss intensive practice 9.1 of chapter 10 solution of triangle. Now we look number 1. The diagram on the right shows a triangle ABC such that angle B equals to 77, angle C equals to 39, and the length AC equals to 40.5. Calculate the value of angle A, the length A, and the length C. So for angle A, you know the other two angles, that is angle B 77 and angle C 39. So the total angle for a triangle is 180. So just take 180 minus 77 degree minus 39 degrees. So you get angle A equals to 64 degree. Then to find the length of A, you know the opposite angle is 64, and you can use another pair that you know is angle 77, and the opposite length is 40.5. So by using sine rule, A over sine 64 equal to 40.5 over sine 77. So A equals to 40.5 over sine 77 multiplied with sine 64. So you get A equals to 37.359. Then angle length C, that means the length of AB over sine 39. The opposite angle is 39 over sine 39 equal to, okay, the pair we know 40.5 and 77, 40.5 over sine 77. So C equal to 40.5 over sine 77 multiplied with sine 39. So you will get 26.158. Now we look question number 2. The diagram on the right shows a triangle ABD. Point C and point E lie on the straight line AD. C and E is on straight line AD. Find the lengths of BE, CE, and DE. BE, CE, and DE. So you can notice here that you have a right angle triangle ABE. So you know the length of AE and also AB. So we can use Pythagoras theorem to solve this question. So we take the longest side, that is 10. 10 square minus one of the short side is 6 square. So we square it, we get 8. Then same goes for CE. So it's also a right angle triangle BCE. So we take the longest side, 10 square minus BE is 8 square. So we get CE equals to 6. DE also the same concept, Pythagoras theorem, because it's a right angle triangle BDE. So the longest side is 17 square, and minus with BE. BE is 8 square. So 17 square minus 8 square, we square it, we get 15. Next, for part B, they asked to calculate all these angles, EAB, BCE, BCD, ABD, and CBD. So EAB. So you know that is a right angle triangle, so you can use the concept of trigonometry, either sine, cosine, or tangent. So we use cosine here, that is adjacent over hypotenuse. So angle EAB is equals to 6 over 10. Cosine EAB equals to 6 over 10. So we solve, we get 53.13. Next is angle BCE. BCE. So you can notice that this BCA is a isosceles triangle. That means these two lengths have this BC and AB has the same length, that is 10. That means this angle A and angle C are same. That's why we get BCE also 53.13. Next, the angle BCD. BCD is just we take 180 minus the angle C, 53.13. So we get angle BCD equals to 126.87. Next, they ask to calculate the angle ABD. ABD is the whole angle here. So you know one of the pair is angle A, that is 53.13, and the opposite length is 17. So here for angle B, the opposite length will be AD. So how to find AD? AD we just find because we know that our DE is 15. So DE is 15. So um, 15 plus 6 is 21. That's why sine ABD over 21 equal sine 53.13 over 17, the pair, angle A and the opposite length 17. So we solve this, we get angle ABD equals to 81.20. Next is angle CBD. CBD. So, CBD is this part. So, you know that CE is equals to 6. So 15 minus 6, you get CD equals to 9. So the opposite length is 9 CD. And you know that this angle is just now angle BCD. Okay, BCD here is 126.87 and the opposite length is 17. So we use this pair. So sine angle CBD equal over 9 equals to sine 126.87 over 17. So we get angle CBD equals to 25.06. Okay, next for part C, explain the ambiguous case in the diagram on the right. So ambiguous case, we can always use this isosceles triangle. That means we will take the triangle D and triangle C. So why we use this? Okay, this triangle. Okay, this triangle, no? BDC. We come back to the concept of ambiguous case. And another triangle that you can use for ambiguous case is BDA. Okay, BDA, the big triangle. That means this length for the first triangle BDC, this length BC, we can move this BC. Okay, we can move this BC to become AB. And for the big triangle BDA, for BDA, we can move AB become AC. That means without changing the length of BD and angle D. So this is you can refer the textbook for the explanation for the concept of ambiguous case. So we have two triangles. Next, for number 3, in the obtuse angle triangle PQR, PR is 14, QR is 6 square root 3, and QPR is 40. So here is the triangle. You can sketch this triangle. So you know one of the pair 40 and the opposite length is 6 square root 3. So the question is take the obtuse angle and find the size of that angle. So obtuse angle here is angle Q. So we want to find angle Q. We know the opposite length is 14. So sine Q over 14 equal to the another pair that we know is 40 and 6 square root 3. So sine 40 over 6 square root 3. So we solve this, we get Q equal to the reference angle will be 60. But since they ask for obtuse angle, so obtuse angle how you get is in the second quadrant. So we take 180 minus the reference angle 60. This is for second quadrant. Sine is positive in first and second quadrant. So you will get 120. So since this obtuse angle, the answer is 120. Next, for part B, calculate the length of PQ. So you want to calculate the length of PQ. First, we have to find what is our PRQ, this angle. So you know this is a triangle, total angle is 180, and you know the value of the other two angles, that is 40 and 120. So you take 180 minus 120 minus 40, so you will get angle PRQ equals to 20. So we can use the concept sine rule, PQ over sine 20, and you can use 14 over sine 120, or you can use another pair, that is 6 square root 3 over sine 40. So here we use 14 over sine 120. So we solve, we get the length of PQ is 5.529. Next, we look question number 4. The diagram on the right shows a square picture frame which is hung by Amira. Using two pieces of ropes, Amira finds that the picture frame inclines towards the right. The angle formed between the longer rope and the frame is 48. So this side is the longer rope, and frame, the angle between these two is 48. The lengths of rope are 20 and 15 respectively. Calculate the perimeter of the frame. So you can label it, this is 20 and the other part will be 15. So you want in order you want to calculate the perimeter, you need this part, this length, and you know this 48 degree and the opposite length, one of the pair 15, this pair we already know, and we know this angle 20, so we can calculate this angle. So first we can sketch this angle. This frame here, just label it ABC. So this 48, the opposite is 15, then 20. So first we calculate angle A, because we cannot straight away calculate angle C because we don't have the information of the length of AB or angle C. So first we have to calculate the angle A. Sine A over the opposite 20 equals to sine 48 over 15. So after we solve, we get A equals to 82.25. So now we can use this information to calculate angle C. Angle C, this is a triangle, so total angle of a triangle is 180 minus the other two angles, that is 48 and 82.25. So angle C equals to 49.75. So from there we calculate the opposite length, that is AB. So C over sine 49.75 equal to 15 over sine 48. So the angle C is, the length C is 15.405. Since this is a square, that means all these four sides of this frame are same. So we take 4 times 15.405. So we will get the perimeter is 61.62. Now we look question number 5. The diagram on the right shows the position of Puan Aziza's house and the house of two children, Amir and Anita. Another child, Aida, wants to build her house such that all three houses of the siblings are collinear. Collinear means it's a straight line. That means Amir, Anita, and Aida should be around here, her house. So another information, the distance from her house and Anita's house to Puan Aziza's house is the same. That means Puan Aziza's house to Anita's house and Aida's house here, the distance must be same. So find the distance between Anita's house to Aida's house. First we sketch where is our Aida's house. So A here represents Puan Aziza's house, B is Amin house, C is Anita's house, and D will be Aida's house. So first we find this angle. This is 120. So it's already given. So the other part will be 180 minus 120, so 60. So since they said that Anita's house to Puan Aziza's house must be same as Aida's house to Puan Aziza's house. So this length AC and AD must be same. And the angle also should be same, 60 and 60. So we can find this angle. This angle is since you know that this is a triangle, so we take 180 minus 60 and 60, so still you get 60. So we can say that ACD is a equilateral triangle. So now we want to find the length. The length, okay, the information that we can find is AC. How to find AC? First, we use this, this pair 120 and 250, and given the length of 150, so you can find angle BAC first. Okay, BAC first, this part. So how to find? So angle A here shows the angle B A and C. So over 150, the opposite length equal to another pair that we know is 120 over 250. So we solve, we get A is 31.31. While we find A, that's the information that we can find. From there, we find angle B. So you know the other two angles, that's 120 and 31.31. So angle B is 180 minus 120 minus 31.31. So you get angle B is 28.69. So from there we find the length of AC. So here they label it as B lah, AC. This is B. AC is equal, they label it as B. This angle. So So B over sine 28.69, that's angle B, equal to 250 over sine 120, the pair that we know. So we know the angle B is the 138.58. So the question they ask distance between Anita's house and Aida's house. Anita is C, Aida is D. CD. So you know another information that we just found earlier, that is this ACD is an equilateral triangle. That means AC should be equal to CD and AD. So CD here, you want to find the distance between Anita's and Aida's house. So must be equal to AC. So since the distance from Aida's house and Anita's house to Puan Aziza's house are same, the triangle ACD is the same. This is equilateral triangle. Thus, the distance between Anita's house and Aida's house is 138.58. So I hope you all understand the explanation given. So thanks for watching.